Okay, so performance. Back to performance. Oh man, there is a couple things we can look at script wise to see if we have um, potential problems or things that we might do to alleviate maybe some issues or some problems. And these things we can do with any settings, with it, for the game itself. But to start out with, let me. I know a lot of this is probably redundant. It's probably boring as all get out. But let me see if I can start out with some basic ideas, and we'll build on it. Okay. So back to the thing here. Um, so you've got. Let's go ahead and do this. All right. So you've got your hard drive, right? Your hard drive is going to feed in to. You're just going to stream in. Let's say this is your game. So your hard drive is going to stream data into your game. Okay. You got your game, and then from there, your game is going to feed your GPU. Okay, and then that's going to feed your monitor. Okay, which is your monitor here. Okay, all right. So if you're looking at performance, if you're going to go here with performance, how fast you can stream the data into the game affects performance. It'll affect load times, um, LOD streaming times. You'll see things pop in. It can affect pop in. Now there are some any settings that we can do to mitigate some of that, and I'll talk about that in a bit. But let's kind of get the basics down first, and then we'll build on it. Your game has to process the data, and then it will send to the GPU data that the GPU must process and then send over to your monitor, things that you see. And things uh, like reshade, I'm going to put reshade up here, and EMB actually sit in between here. So they will intercept calls to the graphic card, and then they will then in turn send the data to the GPU, and that gives them access to things like the frame buffer, depth buffer, your Z buffer, things like that, to where they can manipulate the data before it even gets to your monitor. Now you can change. I believe it's. I don't think it's OMODs, but I forget the actual record that the game uses, which lets you change the colors of the environment, things like that. Like Nax and other weather mods use that. Even the game uses that to some degree. Um, I forget what they're called, but yeah. So, anyways, but let's look at it basically from this point forward. So, how fast you can stream it, and this depends on your CPU, your memory. How fast your memory can handle things. Uh, your GPU, your graphic card, how powerful it is, and the resolutions you're trying to do. Now that's part of the thing that has to do with performance. Um, let's go in here and let's make another one of these. If I can get my little mouse here to work right, let's make another one of these puppies. Okay. So one of the things you want to consider is the high resolution texture pack. Let's look at the textures here. So the Bethesda high resolution texture packs have massive textures. They're massive. They're really wide and they're really tall. Third party texture packs may occupy half that space. And textures, you can have you can have a texture which is the actual texture itself, right? And then you can have another bitmap, which is your specular map. I can't even type. I can't even spell actually. Let's back this up. All right, so it's your specular map, right? And this doesn't necessarily need to be massive. So there are certain optimizations that, like third-party graphics, can give you above the Bethesda official high-res DLC. They can use different compression. They can use different DTX compressions. I think it's DTX compressions, where some are less lossy. It doesn't lose as much of the pixel data during compression. Some might not even be compressed at all. So the more, like, let's say you have a simple outfit, right? Let's say you just got this little outfit. Whoa, I have no idea what happened there. But let's say you got this little outfit, right? All right, just a little outfit, nothing major. And you have your texture. So that's one of these things. And then you have a specular map. Well, here's another one. It's another big chunk of data that may show shadows. You got some kind of like shadows. And then you can have other maps as well. And all of these go into rendering. All of these go into rendering how pixels, or go into how pixels are rendered for the clothing, the face, the head, all that stuff. The bigger these are, and the more of these you have, the bigger the load is on your graphic card, on your GPU. The more GPU memory you're going to need. The smaller these are, the less it's going to be a load on your GPU, and you don't need such a strong graphic card, but it won't look as well. So there's a trade-off between how something looks and playability. I mean, you could load everything up with 8K textures, but it's not really going to look any different on, let's say, a 1080p monitor than 1K textures. It's really not going to look any different, because it's having to downscale. So it's taking something this big and it's trying to downscale it to the size that it can display. So one of the things you can do to improve texture, to improve performance of your game, is install some texture mods, some texture packs that cover most of the in-game textures. That will, like I think, like I say, I think NMC has some, and there's another one. I think it's Performout has some. I haven't really used those yet, where they literally go in and they'll reprocess all the textures of the game so that they're smaller. They take less VRAM out of your GPU. That's less bandwidth that you need from your GPU to move that data, and they look just as good. And I think there's some Bethesda textures they said were specular light reflections on grass was like 4K in size, and you don't need that. That's ridiculous. So they handle that, so it puts less of a load on your GPU and gives you a better frame rate. Okay, so that's kind of like one of the things you want to look at is installing some graphic mods that can take the base game, even the really doesn't change the way it looks, but it changes the size, and it scales down some of the DDS files that really don't need to be that big or that detailed, especially like they say with grass or something like that. Like if you put 4K guns everywhere, you're going to start to notice that your GPU is going to be under a load, where you don't really need a 4K gun. Even though I'm running 5000, I think in the last video I think it says 520, but it's actually 5120 wide pixels. I only use like 2K graphics because there's not really that big of a difference, and it's too big of a load. There's just too much data that I'm trying to move, especially if you have 4K rocks, 4K bushes, 4K plants. It looks good in screenshots, and if you're running multiple graphic cards where you can distribute the load between, you're no longer doing like 16 gigabytes of VRAM or 12 gigabytes of VRAM. You now have 24. You can distribute that load better. But just with a single graphic card, that's way too much. All right, so let me show you some more. Let me show you a couple more things here. Let me put this tablet aside. All right, and let's go ahead and wax these out. Don't need that. Don't need that. All right, let's take a look at the game save itself. So let's take a look at our game save. We're going to do it through Resaver. Now I've added and removed mods, so my game saves are going to be pretty ugly. All right, so I have 10 unattached instances. I'm not too much worried about that at the moment. But what I do want to look at is I want to look at active scripts. So I've got 20 active scripts running. So that means during the interim between rendering frames, the game is literally, now this changes depending on whether scripts fire off other scripts, what scripts are being called, what events are being generated by the game that then triggers scripts to be executed. So looking at just this particular moment in time, it literally has to process in that interim 20 different scripts if it can. So it's going to do a small chunk of this one, small chunk of this one, small chunk of this one, right on down the line, draw the next frame, come back and do it again. If it only gets this far and it needs to draw a frame, once the time slice gets above a certain amount, it's in microseconds I believe, the VM stops processing scripting. It goes back to frame rendering. Then when it comes back, I believe it would pick up where it left off. So if it left off on here, it's going to pick up from here and go forward. Like I say, that's how you get script lag. Now 20 active scripts seems like a lot. I've added stuff mid-game, so it could, I've added and removed mods mid-game. I don't really care about this game save per se. I've saved my settlements as I build on them. I save them back, so I'm not too much worried about this, because I do want to start another game and use replacement mods for some of the mods I'm currently using just to see how it works. But this is something you can look at, and you'll actually notice in the Papyrus there will be, I don't have any here. Let's see if this works here. In the Papyrus itself, I don't think I have any stack overruns. But this is interesting because this is an interesting thing here, because I noticed that this could be from a mod that was removed, and that's why I'm getting a lot of these errors. But I don't see any like stack overruns where it's overflowing. That can cause script lag because that's extra processing. It's not extra processing. It's not even executing the scripts. It's just too much. It's saying there's too many scripts that are queued up. I can't get to them, so I'm going to dump them out in the Papyrus so you can see what I'm not getting to. That will definitely give the appearance of major script lag, and that's one indication you can look out there. You can look at your Papyrus log. I don't have details. I don't put details in here. I just kind of got logging turned on, so you can look at that. One of the things I looked at for you over here was you can see in the ini files in the Papyrus section, you have a couple of variables they talk about. You can see here the post-load update time. This is in, I think it's microseconds. So they have a half a second. I believe 500 is a half a second. So they give a half a second from the time everything loads to give the VM time to get a foothold before it literally puts you into the game. I've got this set to 5 seconds, and that's going to increase loading time by 5 seconds because it gives VM time to catch up. I did this for SS2. I'm not running SS2, so I left this as it is. The budget in microseconds and the tasklet budget. Normally, you can look at the default says it's 1.2, I think, 1.0. So basically, each script, as the VM starts to execute a portion of each one of those scripts, it's allocated a budget time. So I think, like I say, this is 1.2 microseconds. And with SS2, they had you double it because it was script intensive. So in other words, I'm saying that I'm giving it double the standard amount of time to do whatever it needs to do in a script. And depending on the complexity of the script and how many calls it makes, it's going to probably have to use the stack a lot for return calls, and the more that happens, the more calls you have, the more it's going to look like your script is lagging, because not enough of the script is getting done before it has to move on to the next script in that little time window you have in between frames. Another thing you want to look at is the minimum page size. Now these are kind of important, and the maximum memory page size. Alright, so you got the max and min page sizes. Now what that is, there was a lot of confusion about that. Now here's what that is. Alright, let me try to show you this way to see if this makes some sense. Okay, so when a script is running, right? So you've got a script here. Alright, so you got a script that's running. It allocates the minimum amount of bytes to store data. So when this script is running, it stores data in the stack or in a workspace. You could call it, it's not a cache, I forget the term for it, I can't even think. But anyways, it stores this in a working space. If this gets full, this is full, it'll allocate another one. And this is the same script. So if that gets full, it allocates another one. So this script now has to access 3 different chunks of memory in the workspace in order to do what it needs to do. By increasing that, if you increased it to 3 times the size, then this script only has, let's say it only fills up this much. Everything it needs, it's right here. Everything it needs is right here. It doesn't need to go back out into that working space and grab more blocks of data. It's all right here. But you have wasted space, right? So the more you increase this, the larger you increase this size, you're going to have twofold of a problem. One, you have a minimum size, right? I can't even talk. You got a minimum size and a max. Now, the maximum is the maximum number of bytes it'll allocate before it allocates another one, right? Not the minimum. So the minimum is the least amount you think you're going to need, and the maximum is the most you think you're going to use. If you set the minimum too high, then if the script only needs this much data space, and you allocate, and it says, well, the minimum you said you wanted was this much, you only used this much. All of this is unused. And then it allocates the next frame, and then what you have is a lot of just wasted space. All this is wasted. But when the game goes to unallocate this or free this up, it takes longer to free up a bigger chunk than it does a smaller chunk. And you'll notice that kind of lagging too. You'll see because you will get script improvement. The actual scripts seem to run smoother with larger allocations for these frames. But there is a cutoff limit. There is where too big is too big. You're burning too much memory, and you're using up too much of your working set, your working space. What Baka does for scripting is, because the system only allocates so much, the game only allocates so much. It uses its own allocators. Whereas Baka and I think Buffout 4 uses system allocators where it can allocate as much as it needs. Baka gives you 4 times the amount of space. So that's with SS2 and script heavy mods. It gives you 4 times the amount of working space that you need. And like I say, I wish I could think of the term for it, and it does elude me at the moment. But it gives you 4 times the space. That's why they use multiples of 4. You will see some improvement. It looks like the script runs smoother, but you will also create lag when it frees these blocks up because they're bigger blocks, and that's going to take slightly longer to free up. And the more you have of these big blocks, if you set your minimum too high, then every one of them are going to be bigger than what you need. You're going to have a lot of wasted space where it's just not being used, and it has to free all that up. And you will notice that, because I noticed when I set this too high. I was playing around with this one day, and I noticed I set it the minimum up higher than what it should be. It seemed like the scripts run a little bit better, but when I set it too high, it came back to bite me. So the idea is to find the balance between the minimum and maximum sizes. With SS2, I think they doubled. I think their idea is let's just double the values. Let's just go in and double it. And I left the minimum the same because, again, that's the minimum size. If it uses less, like let's say for some reason it needs 64 bytes, it's going to grab 128 instead of 64, and the rest is never going to be used. I left that what Bethesda considered to be the minimum. It's the maximum size that's allocated at any one time. I changed, and you can see that it's doubled. So 5112, you double it, you have 1024. I could even double this to 2048, and I think I doubled it as high as like 4096. And then you have the maximum allocated memory bytes. Now, again, Baka can change this so that the entire working set, your heap, that's what I was looking for. I don't know why I could not think of that, but it's your heap. They call your heap size. And it's just a heap is just a big pile of memory that it uses as a working set. It's where it stores its variables and things that it needs. So as scripts are executing, it can say, okay, I stored this because this other piece of a script's going to need it, so I'm going to pull it off the stack and then I'm going to pass it on. So you can set this. I could set this higher, and I think you could probably set your maximum allocated memory bytes. But without Baka, which I'm pretty sure you have, or Buffout 4, you have memory management in that where the game does its own allocation, but Buffout 4 allows that to use system allocators, so it can allocate more, or it can allocate more memory. And it's the same with Baka. Baka gives you 4 times the heap size, so that way it doesn't have to try to allocate a second heap or a third heap and then flip between all this data. It's just one big mass. And you will see some improvement. But just watch this lower number here, this maximum memory page size. You don't want to make this too big because it'll equate to it'll actually equate to some script lag and a lot of wasted memory space. So that's a couple of things you can look out there. So it's textures. Take a look at your texture packs. Find something that is a performance texture pack, not something that reduces the resolution to where it looks worse. You want something that looks the same or better, but uses less graphics memory. That has it's just going to require less bandwidth from the GPU itself. Same for meshes. Do you really need? I mean, does a person? I'm not saying you personally, but like, does a person really need 500,000 polygons just to draw hair? I don't think so. Because games look really good and it's not required. So it takes and you really have to kind of have a little bit more active thought when you do it. Like, what am I adding to the game? Like, for example, some games can trigger face gen data to happen in real time, to where it's trying to generate, I think it's the tones and the way that NPC faces look, the color of the skin, the tone of the dirt, all those different things. It's trying to generate that on the fly. Whereas if it's already generated, it's going to happen much quicker because the game doesn't have to do any extra processing. It's right there. But that's going to require more memory because you're going, it's kind of a trade-off. Because you're going to have to load that data. You have to provide that data. Um, so you got those things. But I would look at textures first. Find a good texture set and replace the do not use the high res do not use the high res DLC that comes with Fallout 4. Replace it with a performance or another pack that gives you the same quality, but it reduces the size of everything. And then consider using 1K and 2K textures, and even less, depending on what the object is. Do I really need a 2K box of sugar bombs? Does it really need to be 2K? I mean, because it's a little low tiny object, anyways. Does a Tato need to be 2K? So kind of balance that out, and that way you can take an enormous load off the graphic card and the game engine trying to deal with those size of graphics. Um, with vertical blank, if you ever notice, you can have vertical blank on or off. You'll have screen tearing when you turn it off if the graphic card cannot keep up with, or if it cannot keep up with the frame rate. Um, so to get extra frame rates, you can turn vertical blank off, or VSync, if you want to call it VSync, vertical sync. You can turn that off, and you will notice screen tearing because, like I say, it's not done drawing one frame before it has to start on another, and you'll see the difference. When you turn VSync on, it has to wait, but sometimes there's a lot of extra CPU cycles available to render frames that you won't necessarily use because you have VSync on. Now, OpenGL the OpenGL drivers like DirectX. Actually, well, I don't know if DirectX has this. I know OpenGL has it. It's where you can actually render. You can render frames before they're ever used. It's called it's like buffer. It's like a frame buffer. You can say I want 3 frames in the frame buffer. So therefore, when the CPU has time, it renders them, and then it'll use the extra CPU cycles to render whatever it needs, or prepare whatever it needs before it can be piped to the GPU, and that can alleviate some frame rate issues. Um, but like that would be some things to look at as far as just overall game performance and overall, just overall, just performance overall. Um, with what you were talking about with transfer settlements, like I say, it's either too many objects, the objects are too high res, it could be too many lights, which is causing too many shadows, especially if you have a mod in there that dynamically creates shadow from every light source. So it could be how one mod interacts with another mod or changes data that another mod uses, because maybe when he added the light sources, he doesn't have shadows on everything, or every light source doesn't produce a shadow, and he might be using vanilla objects. It could be the fact that it required modded objects that doesn't have it. That really shouldn't matter because it should only render what's in the JSON file, like what. Yeah, that shouldn't cause a problem. But it could be how mods interact with each other. It could be, like I say, texture sizes. It could be the order of your mods where it's causing recursive processing that's not necessary, or unnecessary processing that doesn't need to take place because it's already done some type of processing, but then it hits a mod that says, oh, you changed something that I've already done, so now I got to redo it again. Something like that. Um, so yeah, I mean, it could be that. So I just wanted to toss that at you so that you can kind of see any settings, what that might do, how it may be good or bad depending how it does help. Changing the heap size does help, but you don't want to change these numbers here too high, because there is a cutoff limit to where the VM says I cannot give you that kind of time slice because I am dependent on frame rate, not vice versa. And what you'll see if you give it too high a slice, some scripts may not get executed. And you're going to notice that in some really weird game behavior, because what Bethesda has done is create, like, there's two different things going on. You have visually what you see, and then you have scripting going in the background, which coincides with what you see. And if the scripting in the background gets out of sync or gets way behind what you see, weird things are going to happen. For example, you can have a bullet fire, but you have a scripted sound or a scripted headshot, but that doesn't happen until seconds later. It's like, okay, what happened? It's script lag. So those are some things you can look at. Just let me know what you think, and if you need anything else, and I will see what I can do.